So you may have noticed in example 1 that there's a relationship between the number of permutations and the number of combinations. So, in this case, to count the permutations, I could list all of them, or I can use a formula from the first section that we learned. And to learn the number of combinations, I can write down every possible combo, or I could just take the number of permutations and divide it by a special number. In this case, the number is 6. Why 6? Because that's the same as 3 factorial. And why 3 factorial? Because there are 3 spots in my combination. There are basically, these are 3 combinations, 3 dash combo. Okay, so in this case, to get the number of combinations, or R combinations, we will be using the formula n choose R. And what does n choose R stand for? It's basically n factorial divided by R factorial times n minus R factorial. Okay, so it's basically the number of permutations divided by the size of each of the combo factorial. That's another quick way of remembering it. Okay. Now, the notation that we use for permutations is usually ordered pairs or ordered triplets. So we usually use parentheses with A, B, C. That reminds us of like an ordered pair or ordered triplet. So it reminds us of the x comma y plane and so on. So the order does matter. Whereas with combinations, we use the set builder notation, because with set builders, it does not matter how you write the letters inside. So ABC or BAC corresponds to the same set. So it gets counted only once. So that's the reason why you're seeing some kind of brackets and braces and so on. Okay. So in any case, this is basically the start, and now we have the formula. And just think of combinations as being unordered selections. So you're selecting things and the order does not matter. And again, in these problems, the repeats are not allowed. So the same object cannot be chosen twice. Okay. When the same object can be chosen twice, then we will be calling that something else. That's going to be the next section. Okay, so let's practice some examples. Example 2 says, how many 5-person basketball teams can be made of a group of 12 people? So you have 12 people available, and you want to make the group of 5, basically. Now keep in mind, when you're making the basketball team, you cannot select the same person twice. You have to select different people to fill different positions. So here, the repeats are not allowed. So repeats, not okay, not allowed. And at the same time, the same person cannot be chosen twice. So that's the repeats not allowed. And the order does not matter. If you select the person at the beginning or at the end, they're still going to make it to the same basketball team. They're still going to be playing the same game. Okay, so here the order does not matter either. So the order is irrelevant. Order does not matter. So this tells me that I'm basically making combinations. So I am counting combos. So we are counting 5 combinations out of 12. So this can be counted as such: 12 choose 5, which is the same thing as 12 factorial divided by 5 factorial, and then 12 minus 5 factorial. Okay, so this is how I can count it manually. There's also a command in your TI calculator that can do this automatically for you. So if I'm counting it manually, that would be 12 on the numerator, factorial, divided by 5 factorial times 7 factorial. And you can kind of break it down as much as you want. So this is 12 times 11 times so on and so forth, all the way to 1, divided by 5 times 4 times 3, all the way to 1, and then 7, 6, 5, all the way to 1. That's one way to do it, or you could just use the calculator and the calculator will give you the work. So since you're allowed to use technology, go ahead and use the calculator to find the answer. So when I test it out, I get 792 as a solution. Okay, so that's how many possible groups of size 5 you can have if you have 12 people in the room. Okay. So let's take a look at part 2 of the problem. Suppose that 2 members of the group insist on working together as a pair, and any team must contain both of them or neither one of them. Okay, so now how many 5-person teams can be formed? Okay, so again, you have, let's say, person A and person B, and they like each other. They either want to play together or they don't want to play at all. So how many choices can now happen? How many groups can now be made? Okay, so person A and person B insist on playing together or not at all. So here's how I can count the situation. So what I'm going to do is basically break down what I'm trying to count into two different sets, into two different groups. So in one side, I'm going to count the teams that would have person A and person B on the team. Okay, so these are the teams containing A and B. Now on the other side, I'm going to put all the teams that contain neither player A nor player B. So again, to summarize, my team can either have both players or it can have none of the two players. So if the team has both players, my team has 5 spots to fill. Person A and person B get to hang out in the first 2 places. Regardless of where they are, they could be here in the middle and at the end. Again, it does not matter because the order does not matter in these problems. I'm going to select them first. Now, what's basically supposed to happen? I am supposed to fill the last 3 positions, and how many players are there available? Now, remember there were 12 to begin with. Person A and person B are gone, so now there are 10 people left. And how many do I have to choose out of those 10? I only have to choose 3. So 10 choose 3 will be 120. Okay, so that's how many teams would contain both players A and B. Since A and B have to be on a team, there are less choices for my other 3 spots, so there are less teams in total. So this is how many teams would contain both A and B. Now what about the teams that don't contain A and B? Well, again, I have to make a team of 5 players, but A and B are not here in this team. So how many people remain? If I don't select A or B, and I started with a group of 12, there are now 10 people to select from, and I have to select 5 people this time. Okay, so remember, why is it 10? Because the team does not have the A and B, so they're not counted as part of the 12. And so 10 choose 5 is going to be equal to 252. So that's the size of my choices. That's how many teams are possible. Okay, so if I put my A and B players on a team, then 10 players will remain. I have to pick 3, but if I don't pick players A and B, then 10 people remain, and I have to pick 5 this time. Okay, and so at this point, keep in mind that these 2 sets are disjoint. So the first box and the second box are disjoint. Okay, a team that has players A and B cannot be mistaken for a team that doesn't have players A and B. So what's the total of number of teams possible? I just have to add the 120 and the 252. So since the 2 sets are disjoint, then the number of teams that we have in question will be the sum of the 2 numbers that we got, the 120 and the 252, which is going to be 372 possible teams. Cool, that's it. So now suppose we have a situation where the 2 members in the group don't get along and they refuse to play together on a team. How can you count the number of teams? So in this part 3, person A and person B don't like each other. They don't want to play on the same team. So how can I determine the number of teams that would work in this case? Well, I could kind of imagine a scenario similar to the one I did previously, and I could kind of imagine a giant box. I just have to be more careful here. So in the first part of the box, I'm going to have the teams with A and no B. The second part of the box is going to have the person B, but not the person A. And then finally, the third part of the box is going to have no A and no B. Okay, so that's basically what could happen in a team where 2 people don't want to be together on the same team. And this is perfectly fine. If you like this choice, then you can go ahead and calculate it. I personally don't like that choice because it's going to take 3 calculations to get to the answer, and that's way too much work. There's a faster way to do the problem. The faster way to do a problem is basically to kind of think about the teams in total, like every team in the possible universe, and then take out the teams where the 2 players are together on the team. Okay, so that's basically using the difference rule. So this is kind of the idea. My team can either have both A and B, or every other possible scenario where team has A but not B, or B but not A, or neither A nor B. Okay, so remember, what we're trying to count is pretty much this side of the box. We want to know how many teams have neither A nor B, or A but not B, or B but not A. So that's what we want, and we know that the total number of teams in the universe, all of these teams together, the whole box from part A, it's 792. So the total number of teams in the universe is 792. And we can calculate how many teams have both A and B. We kind of did that already. The number of teams that have both A and B is 120 teams from up here. So by taking the difference, we can tell that the amount that we want, so the total, the number of teams in total that we want, is going to be, using the difference rule, 792 minus 120. So that's a little bit faster, and it's a little bit easier to get the amount over here. Okay, so 682 possible teams, basically. I meant to write 672. Okay, so that's one way to count it. Let me give you on a separate piece of paper how to count it the other way around, okay, using the addition rule. So this is using the subtraction rule. So this is method 2, where we counted the number of teams with the person A but not person B. So remember, your team has 5 people, 1, 2, 3, 4, 5. If you select A on that team, B is not going to be able to select it. So there are 10 people left and you have to choose 4 of them. That's why there's 10 choose 4. In part 2, you selected B to play on the team, and again, A cannot be selected, so therefore there are 10 choices to make and only 4 people are to be chosen from the 10. And finally, the last case, when the team has neither A nor B. So you did not select A, you did not select B. So how many people are left in the world? 10. And you have to select 5 of those to play on the team. Okay. So in total, the answer is going to be again 672 using the addition rule. So this is addition rule. So as you can see, some of the problems can be done in multiple methods. It does not matter which one you pick, as long as you pick one of them and you get the right answer. So that's it.